Hello guys, welcome back for another question from the topic matrices, and let's see what do we have today. We have two matrices. On the LHS we have this matrices, on the RHS we have two matrices, and if I am not wrong I can see that this is if I consider this matrix as A, this is B, then this is B matrix and this is A matrix. So the whole question is that we have to prove that in general AB is not equal to BA. AB can be equal to BA in some special cases, but generally AB is not equal to BA. I mean, the matrix multiplication is not commutative, commutative, and we just have to verify this property. So the question is twofold. First, we have to find the multiplication of both the matrices AB and BA, and then we have to check the corresponding elements of both the resultant matrices. If the corresponding elements of both the resultant matrices are equal, then the matrix multiplication is equal, otherwise it's not. So let's move into the solution. Okay, so on the LHS we have two matrices as the first one A and the second one B, and we have to multiply both the matrices. So I hope you all remember that how we operate the matrix multiplication. In the first matrix we move horizontally, and in the second matrix we move vertically, and then we multiply the corresponding elements in the given direction. I mean the corresponding elements in the horizontal direction and the corresponding elements in the vertical direction. Let me show you one of the example. Suppose we have to find the first element, so we move the corresponding element of 5 in the horizontal direction to the corresponding element in the vertical direction, that is 2. Now the corresponding element of -1 in the vertical direction is 3, and we multiply them and add them, that is 5 into 2 plus -1 into 3. Now let me erase it. Similarly, suppose we have to find the last element, so we multiply 6 into 1, and then we multiply 7 into 4, and then we add them. So we get our LHS as this thing. Remember it, we may need it in the later part. We have our LHS as 7, 1, 33 and 34. Now moving to the next slide, where we have to operate on RHS. Our RHS is B into A. This was B, this is A. Now we have to multiply both the matrices, and our final answer is this thing. This is equal to BA. I hope you all know how to do matrix multiplication by now. So we can see that our LHS is not equal to RHS. I mean AB is not equal to BA. So the question is solved. Now let us move to a slightly difficult problem where the order of matrix is 3. Now it's not 2. So let's see what do we have. On the LHS we again have two matrix, and on the RHS we again have two matrix, and this matrix can be recognized as A, this can be recognized as B, and this can be recognized as B, and this is again A. Now let us move to the next slide. Okay, so first we find our LHS. For finding LHS we have to find A into A dot B. So moving horizontal and moving vertical, we multiply the matrices, and I think I need not to explain how to multiply the matrices. So we get our LHS as this thing. I request you all to remember what is our LHS, or otherwise you can move back in the video later on to find what was LHS. So this is our LHS, and this is equal to A B. Now moving to the next slide, we have our RHS as this was B, this is A, and we have to find BA. Again we multiply both the matrices and simplify the expressions, and we get our RHS as this thing. This is equal to BA. Now if you move back to the last slide, or in the move back in the video, we find that AB is not equal to BA. So our matrix multiplication is not commutative. Our LHS is not equal to RHS. So I think that is it. Thank you. I hope you all got it.